Okay, so these were some general things about this type of functions. And now we will see how specifically how we are going to graph them. Okay, so let's start with a very easy one. Let's start with f of x equals minus x cubed. Okay, we want to graph f of x equals minus x cubed. Okay, the first thing we're going to do is we're going to find the roots or zeros of the function. Okay, that's the first thing. And that means that those are the points where the value of the function is zero. So those are the x-intercepts, the points where I'm crossing, where I'm going to cross the horizontal axis, where the function equals zero. Same thing as we did with quadratic functions. Okay, so how can I do this? I have to solve the polynomial, I have to solve the equation. So if f of x is zero, this means that minus x cubed is zero, okay? And if minus x cubed is zero, this means that x is zero, okay? Of course, I could say that minus x cubed, this minus sign goes to the other side, and so on. Then I make the cubic root, the cube root of zero and everything. I'm just skipping all those steps. If I have minus x cubed equals zero, it means that x equals zero. And this means that the function is going to go through the point 0, 0. Okay. And here, this is the only root I have. Okay, because all of them are the same one. And once I have this root, I'm also going to find a few points. So the first step would be finding the roots or zeros, and then I will give values to some points. Okay. Graphing third-degree polynomial functions is not as accurate as with other functions, so we have to make an approximation. Usually, we can take these values and they will help, okay? We don't need to take all of them, or sometimes we will need more. It depends, but let's use this as a reference. So let's take f of minus 2, f of minus 1, f of 0, f of 1, f of 2. We already know that f of 0 is 0 because it's a root, okay? When x is 0, f is 0, f of x is 0. So let's find this. F of minus 2 is minus 2 cubed. Okay, this is minus 8, so it's positive 8. When it's minus 1, this is minus 1 cubed. Okay, so minus 1, it's positive 1. This one is solved already. F of 1 is minus 1 cubed. So this is minus 1. F of 2 is minus 2 cubed. So it's minus 8. Okay, so let's graph this. I'm going to use 1 square for 2 units, okay, for simplicity. So I have my root at 0, so it's the point 0, 0. I have the point minus 2, 8, so the point minus 2, 8. I have the point minus 1, 1, minus 1, 1. I have 0, 0. I have 1 minus 1, and I have 2 minus 8. Okay, and then this function is, this graph will look like this. Okay, so it's the shape I told you before that was characteristic of this type of function. Okay, as it's negative, the coefficient is negative, it goes down. Okay, So, but as I said, we are doing an approximation. It's not as accurate as with other functions, but we have a very good approximation. And now I'm going to graph another function with more terms. Okay. So I'm going to graph f of x equals x cubed plus x squared minus 2x. Okay. How would it be to graph this function? Okay. Same procedure. First step is finding the roots or zeros, okay? Those are the points where my function is going to cross the x-axis. So, first thing, roots, also called zeros of the function, and those are the points where the function is zero. Then, I have to solve the equation. If this equation is zero, I have to factor the polynomial. Okay, that's the easiest way to do this. I can take a common factor of x, so this is x squared plus x minus 2, okay, and equals 0. And this is a trinomial where I can easily factor because if you remember this, I have to find two numbers that multiplied give me minus 2 and added give me 1, okay? I could do this by using the quadratic formula, okay? The x equals minus b plus minus square root, blah, blah, blah. But if I have an easier way, I will use the easiest way, always. So here, if you realize, I can see that if I put 2 and minus 1 here, 2 times minus 1 is minus 2, 2 minus 1 is 1. So this is my factorization. Okay, so this polynomial, this equation is equivalent to this one. And in this form, it's very easy to find the zeros or roots. The zeros, as you know, are the values of x that will make this equation equal to 0. This expression equals 0. So for this to be 0, I have three options. Either x is 0, that's one option. X plus 2 is 0, or x minus 1 is 0. One of those three options. In this case, x equals minus 2, and in this case, x equals positive 1. So here are my three roots. X equals 0, x equals minus 2, x equals 1. I have my three roots. I'm going to write them here. So my roots are x equals minus 2, x equals 0, x equals 1. Okay, those are my three roots. And now I'm going to erase all of this. And in order to get a better idea of the shape of my function, I'm going to give some values. So let's find f of minus 2, f of minus 1, f of 0, f of 1, f of 2. I already have some of them. Minus 2 is a root. So f of minus 2, I already know it's 0. 0 is a root. So this is going to be 0 as well. And 1 is a root. So this is going to be 0 as well. And in this and this, I can find the value by replacing. So minus 1 cubed plus minus 1 squared minus 2 times minus 1. So you know I'm just taking this expression and I'm replacing this value of x here. Okay, so if I do this, I have minus 1 cubed, that's minus 1. Minus 1 squared is positive 1. So it's 1 plus minus 1. This is 0. This cancels out. And it's minus 2 times minus 1. That's positive 2. Okay, so my solution for this is positive 2. And here I get 2 cubed plus 2 squared minus 2 times 2. So this is 8 plus 4, 12, minus 4, 8. Okay, so I have those 2 points, and those 2 points are the point minus 1, 2, and the point 2, 8. Okay, so I have those points. I have the roots. Then let's make the graph. Okay. My roots are minus 2, 0, and 1. And I also have the points minus 1, 2, which is here, and 2, 8. 2, 8. Okay, I have those points, and I know as the first coefficient is positive, I know it's going to grow. It's more or less clear here, but just in case I'm not sure, I can always check that. So it's going to grow. I can be sure of it. So the function should look like this. It grows, reaches a maximum, goes down again, and then it finally goes up. Okay, and it meets the requirement. It's growing, it goes through the point, so all perfect. I'm going to stop recording here.